What if you never had to wait for a device to charge? Ever again. Today, we're diving into a technology that could make that a reality, the quantum battery. And I'm not talking about a small improvement here. This is a total game changer, a fundamental shift that could change, well, pretty much everything. Come on, we've all been there, right? Staring at that little charging icon on our phone, our laptop, our game console, just waiting. You know that slow, painful crawl to a full battery? It's gotta be one of the most universal frustrations of modern life. But what if that entire wait could just vanish? Okay, so to really get why this new tech is so revolutionary, we first have to understand how every single battery you've ever owned actually works. And the best way to picture it is with a really simple idea I like to call the tiny straw problem. Let's just imagine for a second that your battery isn't some complex piece of chemistry, but it's just a bucket. Its whole job is to hold energy, or, for our example, water. The bigger the battery, the bigger the bucket, right? Simple enough? But here's the catch. You can't just dump all that energy in at once. It has to be fed into the battery little by little, cell by cell. It's like you're forced to fill that whole bucket using just one tiny little drinking straw. That's your bottleneck. That's why you have to wait. And you know what happens if you try to force the energy through that straw too fast, right? You get friction, things heat up, and you risk damaging the battery permanently. That heat you feel when your phone is plugged in, yep, that's the friction. It's basically the battery's built-in speed limit. But what if we could just get rid of the straw completely? This is where things get really, really interesting. To find the solution, we gotta leave the world of normal physics behind and dive into the super weird, super cool world of quantum mechanics. So, the wild scientific principle that makes this all possible is called superabsorption. It's a quantum process where all the little energy particles stop acting like individuals waiting their turn. Instead, they all kind of link up and start acting as one big, coordinated team. So, what does that teamwork look like? Seriously, forget the tiny straw, forget waiting in line. With a quantum battery, it's like all the energy you need for a full charge just poof, teleports into the battery all at once in the exact same instant. Okay, so how does this magic teleportation actually work? Well, let's break it down. First, since there's no straw, the energy particles don't have to line up. Then, through this amazing quantum thing called entanglement, they all link up. They talk to each other. And finally, instead of a slow trickle, they all blink into the battery at the exact same moment, instantly. All right, so instant charging is already incredible, right? But this is where quantum batteries just start to completely break the rules of reality as we know it in a way you would never, ever expect. I mean, think about it. It's just common sense. A giant bathtub is obviously going to take a lot longer to fill with water than a small glass. For as long as we've had batteries, more capacity has always meant more time to charge. That's just how it works. But what if that basic rule of the universe was just wrong? What if, in this quantum world, the giant bathtub could actually fill up faster than the tiny glass? I know, it sounds impossible, but this is the truly mind-bending part of how all this operates. And believe it or not, it does. This is the quantum paradox. A quantum battery's charging speed actually gets faster the bigger it is. The more molecules it has, the more they can team up, and the faster all that energy can teleport in. A bigger battery literally charges faster. Just let that sink in for a second. An entire electric car battery could charge up faster than your phone. That is insane. So I know this all sounds like it's straight out of science fiction. The big question is, when can we actually get our hands on one of these? Let's take a quick look at where the technology is today. Okay, so let's be real. Right now, this is still very much in the lab. The prototypes that exist are microscopic, and they have to be kept at unbelievably cold temperatures. We're talking minus 200 degrees Celsius just to stay stable. And when I say cold, I mean way, way colder than your freezer at home. The number one hurdle right now is figuring out how to make them work at normal room temperature. But the end goal, wow, it's just breathtaking. Imagine a world with no more charging cables at all. You just put your device down on a surface, tap it, and 1 second later, boom, you're at 100%. That's the future this technology is aiming for. So let's just zoom out for a second and look at the big picture here. This isn't just about a slightly better battery. We're talking about a complete revolution, a whole new way of thinking about energy that could replace the chemical principles we've been using for over 100 years. So on one hand, you've got the old way, chemical power. It's slow because of that straw problem, and it gets hot. And on the other hand, you've got the new way, quantum power. It's instant because of quantum teleportation, and because there's no friction, it stays cool. The difference couldn't be more clear.
And that quote really hits the nail on the head. This isn't just about finding a faster way to do the same old thing. This technology could fundamentally change our entire relationship with energy itself.
So I'm going to leave you with this to think about. In a world where every single device you own can be fully charged in a single second, what new possibilities open up? What new things could you create? What would you do with that power?